Good morning, everyone. Today I'm excited to present our paper titled Skill-Based Filtering in CV Search, a categorized approach for data-oriented careers. Allow me to introduce my team. My name is Ketaro Alexander Herman, and my friend is Felix Cristiano Bungaran. We would like to extend our gratitude to our advisor, Dr. Lily Ayu Wulandari, Gina Sain Nabila, and Andin Dwi Novika, whose guidance and expertise have been invaluable in shaping this research. Our paper has been submitted into the EEE International Conference on Industry 4.0, Artificial Intelligence and Communication Technology. The objective of our research is to automate the classification of resume into job roles like data analyst, data engineer, and data scientist. Why is this important? With the rise of data-driven decision-making across industries, organizations are facing the increased need for skilled professionals. However, the recruitment process is often slowed down by the challenge of sorting through large number of resumes, especially with the demand skills right now are data analysts, data engineer, and data scientists have overlapping skill sets. Our goal is to tackle this challenge by creating an automated system that simplifies resume classification and improve hiring efficiency. Let's look at the background. Previous studies in this area have been used machine learning models for CV classification and employed NLP techniques like TF-EDF and word embedding for skill extraction. However, a major challenge remains. Overlapping skills such as Python, SQL make it difficult to distinguish between closely related roles, example like data engineer and data scientist. Additionally, most existing research relies on traditional machine learning approach with limited exploitation of deep learning technique like transformer or bidirectional LSTM. The highlight this research gap we aim is to address creating a system that can better differentiate between roles with similar skills by exploring advanced NLP technique. Now let's move on to the methodology of our research. We begin with data collection, sourcing resumes from job vertices, and we found this platform provides a focused dataset on 3 jobs like data analyst, data engineer, and data scientist roles. Next, we dive into pre-processing. We do preparation technique to prepare the text data for our analysis. This involves several steps, such as text cleaning to remove unnecessary elements, tokenization to break text into individual words or text, case folding to standardize the text by converting into lowercase. Finally, we use TF-EDF factorization to represent the text numerically. For the model we use, we apply 3 algorithms. For the machine learning algorithm, we use 2, decision tree and random forest. As for the deep learning algorithm, we use multi-layer perception or MLP. For the evaluation, we divide into training and test set. For decision tree and random forest, which are machine learning, we use 80% training and 20% testing. And for MLP, we use 80% training, 10% validation, and 10% testing. Now we'll continue with our exploratory text analysis. As you can see, the global workout is combined between the 3 jobs roles, data analyst, data engineer, and data scientist. In the global workout, Python, deep learning, handbook, C appear much often, reflecting their importance across all of the job. For data analysis, there are Python, W, R, which align with the focus role on creating visualization for business insight. Next is data scientist and data engineer. As you can see in data scientist and data engineer, the most common are Python, handhook, deep learning, which are important because they are focused on maintaining data pipelines, expertise in machine learning, data analysis, and advanced modeling technique.
This is the classification table as the result of our experiments using various hyperparameters. We can see that all of the models have strong performance to predict data analysts with 0.96 for decision tree and 0.97 for random forest and multi-line perceptron or MLP, but struggles to differentiate between data engineer and data scientist. The best model is as expected to be multi-line perceptron with the highest accuracy, which at 67% or 0.67. The best model is not selected only based on the accuracy, but also has the highest score overall, which can be seen on the macro average and weighted average part of the table. The reason that all of the models are struggling to predict data engineer and data scientist because of overlapping skills, which has been discussed on the word cloud. The challenges we've encountered in this research were overlapping skills. This caused difficulties for the models to distinguish the roles of data scientist and data engineer. The feature representation or text embedding or text representation using selected method, which is TF-IDF method, may not fully capture the complexity of job-specific nuances. There is also potential data imbalance, which may affect the model's ability to generalize between each roles except data analyst. The recommendations we could suggest for improvements are selecting more advanced deep learning models, for example, bidirectional LSTM or transformer-based models. Data augmentation to create more diverse training data and may reduce overfitting. Feature engineering which focus more on domain-specific skills. Last but not least is expanding the dataset, which we could include more diverse resumes from different regions or industries to capture a wider range of skills on the roles of data scientist, data analyst, and data engineer. Conclusion. That was all of our discussions. We can conclude that our summary of findings is automated resume classification on data analyst, data engineer, and data scientist roles. The best model is MLP, which achieved 0.67 or 67% on the accuracy, but has difficulties to distinguish data engineer and data scientist due to their overlapping skills. Our recommendation for future work is to use more advanced deep learning approaches like transformers, which may improve the accuracy and feature representation. Okay, thank you for the opportunity for us to present this. We apologize if there are mistakes in our words or our deeds. Thank you.